A very good morning, students. Welcome to class 9 science session, and we are dealing with the 10th lesson, that is matter around us. Now in this lesson we have seen what is matter, classification of matter, elements, compounds, mixtures, types of mixtures, and we have also seen the difference between elements and compounds. Remember children, and we saw the separation methods of mixture, and we saw the first method, that is sublimation. A very good morning, students. Welcome to class 9 science session, and we are dealing with the 10th lesson, that is matter around us. Now in this lesson we have seen what is matter, classification of matter, elements, compounds, mixtures, types of mixtures, and we have also seen the difference between elements and compounds. Remember children, and we saw the separation methods of mixture, and we saw this first method, that is sublimations. Today in this session, we will see the other methods such as centrifugation, solvent extraction, simple distillation, fractional distillation, chromatography, and few informations regarding the solution and types of solution. Let's go into the session, children. The next method that we are going to see is the centrifugation. Now centrifugation is a process in which the solid liquid mixture can be separated, and this solid should be an insoluble solid, right? And this can be separated using a machine which is called a centrifuge. Now you can look into the picture. This is the centrifuge machine. Now what happens? The sample is taken in the test tube. You can see the test tube here. So the sample is taken in a test tube, and this centrifuge rotates at very high speed. Now when it rotates at very high speed, what happens? The heavier particles, that is the solid particles, will settle down at the bottom of the test tube, and the lighter particles remains at the top. So only insoluble solids in liquids can be separated using this centrifugation method. Now for example, this method is employed in milk dairies. Now the milk consists of cream, isn't it? The cream can be separated from the milk. The washing machine that we use in our homes is also employing this process, this principle, which squeezes the water from the wet cloths and it becomes dry. And in laboratories, the blood cells are separated from the blood samples using this centrifugation method. The next one is the solvent extraction method. Now solvent extraction method is suitable for two immiscible liquids. Now immiscible liquids is the liquids which do not mix with one another. For example, oil and water. Now when you mix oil and water, it do not mix with one another, and it separates into two layers, isn't it? So those types of liquids or mixtures can be separated using solvent extraction method. And now this mixture is taken in the separating funnel. Look into the picture, children. This is the solvent extraction apparatus, which consists of separating funnel and then stopcock. Now this mixture is taken in a separating funnel. Now when you leave it for a few minutes, it separates into two layers, two distinct layers depending upon the density. Now here you can see that the oil density is much greater than that of the density of the water. So it forms a layer above the water. So this can be separated. Now after a few minutes, what happens? It will separate into two distinct layers where you can see the layer separation very clearly. Now afterwards, this stopcock is open so that only the water layer is collected in a beaker and the separating funnel is left with the oil. So this method is employed in pharmaceutical industries, petroleum industries, to separate the mixtures depending upon their density. Next is the distillation process. Now distillation is a process of obtaining pure liquids from the solution. Now for example, if you have salt and water, which is called as the brackish water or sea water, now the salt gets dissolved with the water, that is the solvent, isn't it? Now the pure water can be separated from the salt using this distillation method. Now the distillation method employs, or it's a combination of evaporation and condensation. What is evaporation? Evaporation is a process in which the liquid gets converted into its vapors. Condensation is a process in which the vapors on cooling is converted into liquid. Now these two processes are employed in distillation. Look into the picture, children. This is the apparatus of simple distillation. It consists of a round bottom flask fitted with the thermometer. Now this salt water is taken in the round bottom flask and a thermometer is fixed. Now the thermometer is fixed in such a way that the tip of the thermometer, you have the bulb at the end of the thermometer, isn't it? So that is slightly above the side tube. Now where is the side tube? You can see a side tube, isn't it? That is called as the condenser, which is fixed with the round bottom flask. So that is the side tube which leads to the conical flask, and inside the condenser you can see a thin tube inside the side tube, isn't it? So that is the path of the vapors. The vapor gets condensed and it is collected in the conical flask. Now you can see clearly, children, there is an inner tube, isn't it? So this is the path of the vapors. Now when it travels through this condenser, there is an ice cold water that is circulating outside, so that converts or cools the vapors and gets converted into liquid. So the salt water is taken in a round bottom flask. It is allowed to boil, and when it reaches the boiling point, it gets converted into its vapors, and the vapors travels through the condenser, gets cooled, or it is condensed by the ice cold water, and the pure water is collected in the conical flask. Now this method is also used to separate two liquids. Now here I said the salt solution, which is the salt mixed with the water and forms salt solution, and it is separated, isn't it? Now this is also used to separate two liquids. If two liquids are miscible or getting dissolved with one another, this can also be separated, but the condition is the boiling point of two liquids should be, the difference between these two boiling points should be more than 25 K. Only then this method is employed. So two liquids which are miscible can also be separated using this distillation process, and this distillation process is employed in many countries to convert the sea water into the drinking water. Hope you understood the distillation process clearly, children. Now the next is the fractional distillation method. This is more or less like a distillation method. You see the apparatus, children. It is the same as that of this distillation method, but a fractionating column is added or attached with the round bottom flask. Look into the picture, look into the diagram, the apparatus for fractional distillations very carefully. You have a round bottom flask and it is fixed within fractionating column. Then the thermometer is fixed at the tip of the column, isn't it? And a side tube is the condenser which leads to the beaker or the round bottom flask where the pure liquids is calculated. This is more or less same as that of the distillation method, but the fractionating column is employed or it is attached with the apparatus. Now this fractional distillation method is used to separate two or more miscible liquids. When two or more liquids are miscible or mixed with one another, these two can be separated, or the liquids can be separated using this method, but the condition is the difference between their boiling point is less than 25 K, right? And the fractional distillation is used in the petrochemical industries, especially the different byproducts of the industries can be calculated or can be separated using this method. And it is also used to separate different gases from the air to distill alcohols. Distill in the sense to purify, to get a pure 100% pure form of alcohols. This method is employed. Now in this method, children, Alcohol and water which are miscible with one another is taken in a round bottom flask. Alcohol's boiling temperature, boiling point is less than that of water. So it gets converted into vapors first, and it gets passed through the condenser, and it is collected in the beaker at the end of the condenser. So pure alcohol will get collected in the beaker and water remains in the round bottom flask. So these two miscible liquids is separated using this fractional distillation method. Now the next is the chromatography. Now before we go into what is chromatography, we have to understand two important terms, that is absorption and adsorption. What is absorption? Absorbing in the sense it gets distributed throughout the bulk of the substance. For example, if I take a piece of chalk and dip it in water for a few minutes, what happens? The water, the solvent goes deep into the chalk paste due to absorption. That is, it is uniformly distributed throughout the chalk. So that is called as absorbing. Absorbing in the sense the water gets absorbed by the chalk. So when you break the chalk and see even inside the inner part of the chalk, you can see that the water is absorbed till the core of the chalk piece. Now similarly, you take a chalk piece and dip it in ink for few seconds. Now what will happen? The color of the ink is deposited on the top layer or the upper surface of the chalk. When you break the chalk and see, the inner part, the core inner part will be white, right? From inside it will be white, but outside it will be, now if I dip it in blue ink, it will be a blue color chalk, isn't it? So this is the substance is concentrated only at the surface of the other substances. So here the ink gets deposited on the surface of the chalk. So that is called as adsorption. So adsorption is a process in which the substance is concentrated only at the surface of the other substance, while absorption is a process in which the substance is going deep into the bulk of the other substances, or you can say technically it is uniformly distributed throughout the bulk of other substances. Now we'll see what is chromatography. Now the chromatography is the method in which the different colored dyes or different constituent colors or constituent dyes are mixed in a same solvent. When it is mixed in a same solvent, it can be separated. Now this, how it can be separated? What is the principle? It is because that the mixture have different solubility but in the same solvent. Now I'll give an example, children. For example, you are going to mix salt and sugar in water. Now I have two beakers consisting of water, right? Now with one beaker I add salt, with the other beaker I'm going to add sugar. Now I'm taking the water to be equal, that is I'm taking 100 grams of water in both the beakers, but I'm going to add sugar in one beaker and salt in one beaker. Now the solubility of salt in 100 grams of water is 36 grams. Now about 36 grams, how much ever salt you add to the 100 ml of water, it do not mix. So the solubility of salt in water is 36. Now when you take sugar, you can mix up to 200 grams, approximately up to 200 grams in 100 ml of water. So the amount of the water is same, that is same solvent, but the solubility differs, isn't it? So similarly, this chromatography method is used to separate components of a mixture based on different solubility in the same solvent. Now here we are going to see about paper chromatography. Now types of chromatography, there are different types of chromatography, but now we are going to see about paper chromatography. Now using this paper chromatography, we can separate different color dyes in the sample of ink. For example, you have black ink, red ink and blue ink. So you have different types of ink, isn't it? So the different color dyes are mixed in the ink, and this different colored molecules can be separated, that is the dyes can be separated from the sample of ink. Now for that you have to take a beaker in which these dyes are soluble, that is the suitable solvent has to be taken, isn't it? So that is taken in a beaker. Look into the picture, children. So we are taking a beaker which consists of the solvent. Now a chromatography paper is taken and a spot of ink is placed at the bottom of the chromatography paper. Now this paper is dipped into a suitable solvent. Now it has to be separated into its colored dye, isn't it? Now when the solvent moves into the paper, up into the paper, the solvent get absorbed by the paper, isn't it? So when it moves up into the paper, the different colored dyes that is present in the ink will have different solubility, isn't it? So depending upon their solubility, you get different colors on the chromatography paper. Now for example, if you take black ink, you will get 3 different colors like purple, yellow, etc. So this different colors that is present, that appears on the chromatography paper, will give you the idea of how many constituent dyes are present in the ink. Now in black ink you will have 3 constituent colors, which shows that the black ink contains 3 dyes. So this can be separated, that is the colored dyes, the number of colors dyes that is present in the ink sample can be separated using this chromatography. Now we have seen all the methods of separation of mixtures, isn't it? Now look into the table, children, 10.3. Now here the types of mixtures are given and the methods of separation of the types of mixtures are given in table, isn't it? Now in types of mixtures we have 2, that is heterogeneous mixtures and homogeneous mixture, isn't it? Now in heterogeneous mixture, if the mixture is solid and solid, now this can be separated using the methods like hand picking, sieving, magnetic separation, sublimation, etc. Now hand picking is that if the rice is mixed with the dust particles, bigger dust particles, that can be hand picked. Hand picking is that you are picking the impure substances and make it pure. So that is hand picking. Magnetic separation we have seen, isn't it? When a mixture of iron and sulfide are mixed together, you can bring a bar magnet and separate the iron, isn't it? So that is the magnetic separation. So these two are the solid and solid mixtures. So these methods are employed to separate it. Now in heterogeneous, the other one is insoluble solid and liquid. So that is the centrifugation method. We said that the insoluble solids that is present in the liquids can be separated using centrifugation method. The next is sedimentation and decantation. The sedimentation, for example, if you have sand and water mixed together, when you mix it together, after sometimes what happens, it will settle down at the bottom of the test tube and you will get in clear water at the top. So this can be decanted. Decanted is filtered and sedimentation is settling down. So after settling down, it can be filtered. Next is in heterogeneous mixture, you have 2 immiscible liquids. Immiscible liquids, I said, it is not mixing with one another, isn't it? So for example, you said oil and water, so that can be separated using separating funnel, that is solvent extraction method. The next is the homogeneous mixture. Homogeneous mixture is one where it has a uniform concentration. The first one is the soluble, solid and liquid. So that is salt in water. Salt is soluble in water, isn't it? So this can be separated using evaporation or distillation. The next is 2 miscible liquids. Miscible liquids in the sense these 2 liquids will mix with one another. For example, alcohol and water we said, isn't it? When they are mixed together, they get mixed with one another. They get dissolved with one another. and this can be separated using fractional distillation. The last one is solution of two or more solids in a liquid. So that is the chromatography. We said that different color dyes are dissolved in the sample. So this, in a sample of ink, the color dyes can be separated using the chromatography methods. So this table is very, very important, children. So learn the table and understand it. Next, we'll move on to what is solution. Now, what is solution, children? We know it very well, isn't it? For example, salt solution, sugar solution, etc. Now, what is the salt and what is this water? Now, a solution is the homogeneous mixture of two or more substances. Homogeneous mixture, it is uniform. The concentration is uniform throughout the solution. Now, in this solution, the salt is added to water, isn't it? The salt that is added will be in lesser amount by weight, and it is called as the solute, right? And the component which is present in larger amount is the water, isn't it? So that is the solvent. Now if you take the salt solution, salt is the solute, and the water in which the salt is added to it or dissolved it is called as the solvent. So solution is prepared when solute and solvent are mixed together or added together. You get an solution. Example is salt plus water or sugar plus water. So this will give you the solution. Now we'll see the types of solution. Now there are three types of solution, children. For example, true solution, colloidal solution and suspension. Now we'll see the examples of it so that you can understand this types of solution. True solution. Now this true solution example, I can say sugar plus water. The solute is the sugar, isn't it? So sugar is the solute, isn't it? So this gets completely mixed. The particle will not be seen in the solution. We get a clear solution. The particle will never settle down. The particle is not seen through our naked eye. It gets dissolved with the water. Now the particle size also matters in the classifications of solution. Now the particle size should be less than 10 to the power of minus 7 centimeter for true solution. The particles will be very, very small and it gets dissolved with the solvent. The next is the colloidal solution. Colloidal solution example is starch and water. When you mix starch and water, you get a cloudy mixture, isn't it? So that is called as colloidal solution. When you see the particle size is between 10 to the power of minus 7 centimeter to 10 to the power of minus 5 centimeter. The particles are little bigger than the particles in the true solution, and this will not settle down at the bottom of the test tube when you leave it after sometimes. Even when you leave it for hours together, this will not settle at the bottom of the test tube. This will get coagulated with the solvent. The next one is the suspension. Here the particle size is greater than 10 to the power of minus 5 centimeter. It is much greater than the particles in the true solution and the colloidal solution. Now since the particle is bigger, right, when you allow it to settle down, now it will form a turbid mixture, right? Now when you allow it to settle down, it will settle at the bottom of the test tube after some time. Example is flour, wheat flour. Wheat flour, we make it chapati, isn't it? So that is wheat flour. When it is mixed with water, first you will get a turbid mixture. Then afterwards, when you allow it to settle down, it will settle at the bottom of the test tube, and this is called as suspension. So this is about the three types of solution. Next we'll move to colloidal solutions. Now colloidal solution is then heterogeneous solution. Now you have two phases in this, two constituent, or you can say it consists of two phases. One is the dispersed phase and the other one is dispersion medium. Now what is dispersed phase or what is dispersion medium? Dispersed phase will always be the solute that is added. Right? We have, for example, if you say solution, I said solute is added to solvent, isn't it? Similarly, the dispersed phase is nothing but the solute, and dispersion medium is nothing but the solvent in which the solute is added. Now there are 8 possibilities of different combinations are given, and you are given in tabular column, which consists of the dispersed phase and dispersion medium, and the examples are also given. And how is this colloidal solutions called, as the name of it is given in a tabular column. This tabular column is very, very important because in objective types, this questions from this tabular column is asked for the objective types. Now look into tabular column 10.4, children. You have a table, isn't it, which consists of dispersed phase, dispersion medium, name, and example, isn't it? The dispersed phase is nothing but the solute, dispersion medium is the solvent, the name of the colloidal solution is given, and example is given, right? Now see the first one. The solute that is added is the solid, and the dispersion medium is also solid. The name that is given is solid, sol. Examples are alloy. Now alloy is the mixture of the metals, isn't it? Alloy is nothing but the mixture of 2 or more metals. Now here one metal is mixed with the other, isn't it? So the solute and the solvent both are solids. Similarly, you can say oil in water, emulsion. Emulsion is the name given to the colloidal solution. See the example 5, children. Dispersed phase is liquid, dispersion medium is liquid, and the name of the colloidal solution is emulsion. For example, milk, butter, oil in water. Now oil is the solute that is added to water, that is the solvent. So when these two are mixed together, you get an emulsion, which is the colloidal solution, right? So it is the dispersed phase is liquid and dispersion medium is liquid. So this tabular column is very, very important. See to that you memorize the examples and the name of it, so that it is helpful when you do the objective questions. Now look into the last example, children. Gas, dispersed phase is gas and dispersion medium is liquid. Now the example is aerated water. Aerated water is the carbonated water. Carbon dioxide is mixed with water, isn't it? So what is that gas that is mixed? Carbon dioxide. It's a gas, isn't it? So that is the solute in which it is mixed with water. So the dispersion medium is liquid. So gas, liquid, colloidal solutions are called as aerated water. It is called as foam, and example is aerated water. Soap lather. Soap lather is in the sense the soap lather that you get when you rub the soap against your skin, isn't it? So it consists of the gas in the liquid solvent. So far in this session, we saw about the different methods of separation, that is centrifugation, solvent extraction, simple distillation, fractional distillation, chromatography, and we saw about the types of solution, isn't it? Now we saw about the colloidal solution also. Now in the next lesson, we'll talk about we'll learn about the Brownian movement, Tyndall effect, and the emulsion, and we'll compare or we'll see the difference between the types of solution, that is true solution, colloidal solution, and suspension, right? And your homework for today is that you're going to learn the table 10.4 thoroughly and the different methods of separation of mixtures. Go through all the methods, learn the methods, and see to that you draw the distillation and the fractional distillation diagrams properly. So practice it 1 or 2 times so that you can draw it properly. And now your homework for today is that you are going to write the tabular column 10.4 in your science homework note. So get the books from the office, and you will be given 2 unruled note for science. So one you keep it for science homework, the other for classwork, and in homework you are going to copy this table 10.4. Notes are given to you children for the first lesson. Copy those short answers, that is, answer very briefly and answer briefly in your classwork, and submit the classwork in the school office. See you in the next session, children. Thank you.